Hello everyone. In this video, I'm going to be focusing on earth pressure with a specific focus on active earth pressure. So earth pressure in general is a pretty important topic in geotechnical engineering and is extremely relevant in bridge abutment design. So first off, I want to start by refining our definition of earth pressure from what is presented just in the basic course. So there are three kinds of lateral earth pressure, and two theories we will overview. We're going to start with active earth pressure. This is, in my opinion, the easiest to understand. So you can imagine a retaining wall here in blue, and the active earth pressure is a pressure that would occur if we move the wall deflects slightly, leaving a gap between the soil and the wall here. The soil wants to fail at its failure plane, which is a function of phi, its internal angle of friction. And that wedge of soil will put an active pressure on the wall based on depth. That active lateral pressure, or horizontal pressure, pH, is then just going to be our vertical pressure, which is a function of the specific weight or the unit weight of the soil, its density, and the height of the soil column, multiplied by Ka, the active earth pressure coefficient, which takes our vertical pressures and translates it into a horizontal pressure. So pressure is formed in a triangular fashion, which I've shown here below, with the maximum being, like I said, the density times the height times Ka, that maximum load at the very bottom there. And we can use the area of the triangle to get our resultant, which is going to look like this, occurring at the centroid of the triangle. And that will be our active earth pressure resultant. And we'll go in through an example of that a little further down in the video. So don't worry about that too much just so far. Just remember that this is the concept of active earth pressure. Now, passive pressure is the opposite of active earth pressure. And it's a situation where the soil would be compressed by the wall. You can see here, our wall is in red. And if that wall is wanting to deflect towards the soil and compressing the soil. The passive wedge of soil resists this through its shear strength, also dependent on its failure plane and angle of internal friction. Passive pressure is typically ignored in shallow foundation applications, and we will ignore it for our design purposes. I just wanted to give you an example of what passive pressure is. And once again, our lateral pressure, lateral resistance based on passive pressure is found using the passive pressure coefficient Kp, which is going to be different than our Ka. And finally, we have at-rest pressure. So at-rest pressure is a form of active pressure, and it's a more conservative case. This is when something is restricting the wall from moving slightly. The typical example, or the well-known example, is a basement wall fixed into the floors above. So the pressure buildup is more significant because this wall hasn't moved a little bit and it's letting the soil kind of fail and fall onto the wall. It's snug up against the soil, so there's more pressure building up. That's the way I like to think of it, at least. So generally, we'll use the at-rest pressure with the at-rest pressure coefficient of K0 or K0, also to modify our vertical pressure into a lateral pressure. And I've shown below these three cases. We have our three situations in which a triangular pressure distribution is forming from the soil on our example retaining wall, which can be likened to the back wall and anchor of the bridge abutment.